Hey guys, this is a little video to show you how to use the spreadsheet that I made to try and practice energy flow diagrams. This is the sort of thing that will be on not only data tests but on the external exam as well. So it's a really good resource to use to practice and make sure that you've got your calculations down pat. Now you'll notice down the bottom there's quite a few different versions of this sheet, so you've got plenty to practice with. And I'm just going to take you through a few of the basics first, and I just better reset my diagram here. Essentially, if you look at it, it's just basically a diagram that draws information that's been calculated in a little hidden table that's over here. I've actually squished it up there so you can't accidentally damage it. But there's a hidden table in there, and the information from that just gets shunted to this diagram. And the way I figured it out is this. Basically, we've based all of these numbers using a starting amount of solar radiation and these estimates on the efficiency for each of the organisms in these levels for how well they store the food in their tissues. So this little percent here, that tells me how well these guys here, the producers, take the energy that they're given and store it in their body. The rest is lost as respiration and waste. So the producers here, there's a packet of energy that comes in here, a packet of energy that's not lost to solar radiation. I mean, look at how much is lost because it's reflected off. Only a small amount of it actually comes in here. 8% of that energy that comes in is actually stored in their tissues, and the rest is lost to respiration and waste. Same too here. These first order consumers here, they work at an efficiency of about 12%. That's unique to them in this situation. So whatever energy comes into them from the producers, and in this case you've got that number there, 192015, 12% of that gets stored in their tissues. The rest is lost as respiration and waste. And that pattern follows all the way down until you get to the end of your energy diagram. Of course, all of the waste that these guys have, well, it gets shunted into the decomposers. They never go hungry. They're quite happy, these guys. So those decomposers are getting all of that energy and they're eating that. And even when they die, they become their own waste. So they recycle back into the system. So the only thing you have to worry about with decomposers is what they lose through respiration. And so that's basically how this diagram works. All of these little values here are calculated, and you can then basically just use these little shapes here to cover up different numbers on your diagram. You can go and look at a few others if you remember the answers and then come back later. And basically you just have to use this diagram and these cover-ups to figure out some of the unknowns. Can you figure out, say, what the amount of energy that was lost as waste is? If you know that this is how much energy they've eaten, that's how much was stored in their tissues, this is how much they lost to respiration. So if you started off with 192015, take that, take away the respiration, take away the amount stored in their tissues, you're going to be left with 50,692. That's the leftover. Essentially, these three numbers have to add up to what they ate at each level. Okay? If you really need to get your head around that, I always think of it like a triangle, like this. All of this goes to those three places there. Okay? So that's pretty much the pattern. All you have to do is cover up a few of the numbers and see if you can figure out the unknowns. That's what this diagram's about. A few other things down the bottom here. We talked about gross primary productivity and net primary productivity. Now, if you remember from lessons, gross primary productivity is how much energy actually got into the system, into the producers' bodies. Now, I've deliberately, and it might be a little bit of an oversight because I think it's going to confuse you guys, I've deliberately left it out here, this gross primary productivity, to see if you can remember how to work it out. The gross primary productivity is the amount of energy that the producers absorbed, including the energy that they lost to respiration and to waste. So gross primary productivity, how much this actual little arrow here is worth that went into them, is going to be these three numbers added up, and that's the answer there. Okay, so that's the gross primary productivity, how much energy the producers got given by the sun. I've got it listed down here in two different forms because a lot of the time they'll talk about gross primary productivity. They'll shorten it to a power of 10. Okay, so instead of 240,019, especially in biology, it's usually a much bigger number than that. They actually shorten it down to scientific notation, and it would be shortened down to this version here. So they'll always shorten it down to one number and a decimal. So they've moved the decimal back 5 places here, made that 2.4 times 10 to, how many times do I move my decimal? 5 places. There's the 5 there. Okay, so they'll shorten these numbers down and write them like that. So that's why they look like this on here, just so you can see the two different versions of how they write it. Net primary productivity we talked about in class 2. That is how much energy came into the system, your gross, so that number there, minus how much energy was lost as respiration. And remember, respiration is considered lost because once it turns into heat, which is what happens when you lose it in respiration, the plants can't absorb heat. They can't use it again. They can't recycle it. It's essentially lost to biological organisms when it's turned into heat. We can't use that, and that is actually lost to the system. Whereas this energy here, that's not actually lost because, yes, it's waste, but then it actually gets incorporated into decomposers, and they've used it. The only thing that's considered lost is the respiration. Okay, so net primary productivity is your gross primary productivity minus what you lose as respiration. Okay, and that's that number there. So again, you can use your little colors here to cover up these ones here and try and figure out what gross primary productivity is, and then check your answer. Okay, it's pretty simple how I've set this up. It's what you make it. Okay, so you just cover up, I thought, 3 at a time and use the other numbers to figure out what you can't see. Last but not least, this little kill off the trophic level thing I added. That's because some of the higher level questions I'll ask you is, what if an entire trophic level gets removed from a system? If we say lost our first order consumers here, I'm just going to move these little shapes to the side. If something came through, these were removed from the system, what then would happen? Now, we know that the other guys above them are not going to die, but they are going to find an alternate food source. So if something happens to these first order consumers, every bit of energy that they would have had, including respiration and waste, all of that energy is going to get shunted down to the next level. Okay? So if that's the case, how would the numbers change? You have to have a think. I'm just going to zoom in a little bit here. Down. Okay. So if this whole number here, I'll move that down just a little bit, that whole number there got shunted down to our second order consumers, and that means that these numbers here are going to change. Now the first thing you have to do is figure out how much they're going to put into their tissues. Remember how I said that percent there relates to the level below it? These second order consumers will take whatever they eat, and 7% of that will make it into their tissues. The rest of it is lost. So in this case, instead of eating these guys, they're now going to be eating, I might start with a different color here, these guys here. So they're now going to get 7% of 192,015, and that's going to then go into their tissues. So that number will change. So I know 10% is going to be 19,201. So it's going to be less than 19,000. I haven't got a calculator with me, but you need to work that out, and then you can check your answer. And I'll show you how. So you work it out, and then you check your answer. So we're killing off the first order consumers. They're the 1, 2, second trophic level down. So it says over here on your instructions, do you want to kill off a trophic level? Type Y into the grey cell beside the level you want to kill. I want to kill off level 2, so I'm going to type in a Y here. And look what happens to the numbers. It will actually calculate this based on that percentage, and you can check your answer. So that's how that little thing works. If you delete a trophic level, what's going to happen? Okay, these numbers here you can't actually figure out easily because that's a hidden calculation in the system, but you can certainly use these little covers here to then go, okay, if he's now storing this much energy and he's lost that much to respiration, how much is actually going into waste? And you figure out the leftover. Okay, so I'd be going, he ate this much, minus that much, minus that much, what's left over? So this spreadsheet basically is up to you as to how much you use it, okay? You actually have to get in here, cover a few things up, work things out, and check your answers. That's what it's all about. You have 1, 2, 3, 4, 5, 6, 7 different versions of this spreadsheet to play around with. And you can just reset them each time, move these around each time to try different versions. So you've got plenty to play with there and have some practice on. This I expect you to be using as a resource, not just for upcoming data tests, but definitely right up until your external exams. Okay guys, that was a really long cast, but I hope that makes sense. Good luck.